When installing a subpanel in a garage, several requirements must be met for the main breaker to ensure safety and proper operation. Firstly, the amperage rating of the main breaker must be equal to or greater than the total amperage of all the circuits in the subpanel. This ensures that the breaker can handle the maximum potential load without tripping unnecessarily. Secondly, the location of the main breaker is crucial. It must be located in an accessible and visible location inside the garage. If the main panel is outside and within 10 feet, the subpanel should ideally be placed within a reasonable proximity for easy access. Thirdly, the type of main breaker is important. It must be a dedicated main breaker specifically designed for use in subpanels. It should be labeled as a main lug-only breaker, indicating that it is intended to be the primary disconnect for the subpanel. Fourthly, circuit protection is a key function of the main breaker. It must provide overcurrent protection for all the circuits in the subpanel. This means it must be capable of interrupting excessive current flow in the event of a short circuit or overload, preventing damage to the wiring and equipment. Fifthly, the wire size connecting the main breaker to the subpanel must be appropriately sized for the amperage of the breaker. The wire size must be listed in the subpanel specifications to ensure it can safely handle the current. Sixthly, proper grounding is essential for safety. The main breaker must be properly grounded to the grounded neutral conductor of the electrical system. This ensures that any fault current is safely discharged to the ground, minimizing the risk of electrical shock. In addition to these requirements, there are some additional considerations. The subpanel should be clearly labeled to indicate that it is a subpanel fed from the main panel. This helps to avoid confusion and ensures that anyone working on the electrical system is aware of its configuration. The subpanel should incorporate safety features such as surge protection and arc fault breakers for added protection against electrical surges and arc faults. Regular inspection of the subpanel and main breaker by a qualified electrician is essential to ensure they are in proper working order. This includes checking for any signs of damage, loose connections, or other potential problems. In summary, the requirements for a main breaker on a subpanel in a garage include adequate amperage rating, accessible location, dedicated breaker type, overcurrent protection, appropriately sized wiring, proper grounding, clear labeling, and regular inspections. These measures are essential for ensuring the safety and reliability of the electrical system. Let's delve into each of these requirements in more detail. Starting with the amperage rating, it's crucial to calculate the total load that the subpanel will be carrying. This involves adding up the amperage of all the individual circuits that will be connected to the subpanel. For example, if you have 3 15-amp circuits and 2 20-amp circuits, the total amperage would be 3 times 15 plus 2 times 20, which equals 85 amps. Therefore, the main breaker on the subpanel should have an amperage rating of at least 85 amps, or preferably a slightly higher rating to provide some headroom. Next, let's consider the location of the main breaker. As mentioned earlier, it should be in an accessible and visible location inside the garage. This is important for several reasons. Firstly, it allows you to quickly and easily disconnect power to the subpanel in case of an emergency. Secondly, it makes it easier to perform maintenance or repairs on the subpanel. Thirdly, it ensures that the breaker is readily accessible for inspection. The type of main breaker is also a critical factor. A dedicated main breaker designed specifically for use in subpanels is essential. These breakers are typically labeled as main lug only and are designed to be the primary disconnect for the subpanel. Using the correct type of breaker ensures that it will function properly and provide adequate protection. Overcurrent protection is another key function of the main breaker. It must be capable of interrupting excessive current flow in the event of a short circuit or overload. This is typically achieved through the use of thermomagnetic breakers, which trip when the current exceeds a certain threshold. The breaker should be sized appropriately for the circuits it is protecting to ensure that it will trip quickly and effectively in the event of a fault. The wire size connecting the main breaker to the subpanel must be appropriately sized for the amperage of the breaker. Using undersized wiring can create a fire hazard, as the wires may overheat and melt. The wire size must be listed in the subpanel specifications to ensure that it can safely handle the current. Consult the National Electrical Code, specifically Table 310.16, for appropriate wire sizes based on amperage and wire insulation type. Proper grounding is essential for safety. The main breaker must be properly grounded to the grounded neutral conductor of the electrical system. This ensures that any fault current is safely discharged to the ground, minimizing the risk of electrical shock. The grounding conductor should be sized appropriately for the amperage of the breaker and should be securely connected to a grounding electrode system. Clear labeling of the subpanel is also important. The subpanel should be clearly labeled to indicate that it is a subpanel fed from the main panel. This helps to avoid confusion and ensures that anyone working on the electrical system is aware of its configuration. The label should also include information such as the voltage, amperage, and the date of installation. Safety features such as surge protection and arc fault breakers can provide added protection against electrical surges and arc faults. Surge protection devices protect against voltage spikes that can damage sensitive electronic equipment. Arc fault circuit interrupters, or RF-size, detect arc faults, which are a common cause of electrical fires. Regular inspection of the subpanel and main breaker by a qualified electrician is essential to ensure they are in proper working order. This includes checking for any signs of damage, loose connections, or other potential problems. A qualified electrician can also perform tests to ensure that the breaker is tripping properly and that the grounding system is functioning correctly. Now let's discuss some specific scenarios and considerations related to installing a subpanel in a garage with 7 circuits. Firstly, determine the purpose of each circuit and the expected load. Will these circuits power lighting outlets for tools, appliances, or other equipment? Based on the anticipated load, calculate the required amperage for each circuit. For general lighting and receptacle circuits, 15 amp or 20 amp circuits are typically sufficient. For larger loads such as power tools or appliances, dedicated 20 amp or 30 amp circuits may be required. Once you have determined the amperage requirements for each circuit, add them up to determine the total load for the subpanel. This will help you select the appropriate size for the main breaker and the wiring feeding the subpanel. Consider future expansion when determining the size of the subpanel and the main breaker. It's often a good idea to choose a subpanel with more spaces than you currently need, as well as a main breaker with a slightly higher amperage rating to allow for future additions. This will save you the hassle and expense of having to upgrade the subpanel later on. When running the wiring from the main panel to the subpanel, be sure to use the correct type and size of wire. The wire must be rated for the amperage it will be carrying, and it must be suitable for the environment in which it will be installed. For example, if the wiring will be exposed to moisture or corrosive substances, you will need to use a special type of wire that is designed for those conditions. Ensure that the wiring is properly supported and protected. Use conduit or cable trays to protect the wiring from physical damage and secure the wiring to the walls or ceiling using appropriate fasteners. This will help to prevent the wiring from sagging or becoming damaged over time. When connecting the wiring to the main breaker and the subpanel, be sure to follow the manufacturer's instructions carefully. Use the correct tools and techniques to ensure that the connections are secure and reliable. Loose or improperly connected wiring can create a fire hazard. After the subpanel is installed, it is important to test it thoroughly to ensure that it is working properly. Use a multimeter to check the voltage and amperage on each circuit and verify that the main breaker is tripping correctly in the event of a short circuit or overload. Finally, it is important to obtain all necessary permits and inspections before installing a subpanel. This will ensure that the installation meets all applicable codes and regulations and that it is safe for use. Contact your local building department or electrical inspector for more information on permit requirements in your area. Installing a subpanel in a garage can be a complex project, but by following these requirements and guidelines, you can ensure that the installation is safe, reliable, and compliant with all applicable codes and regulations. Remember to consult with a qualified electrician if you have any questions or concerns. It is also important to consider the specific requirements of the National Electrical Code, or NEC, which provides detailed guidelines for electrical installations. The NEC is updated every 3 years, so it's important to stay up to date on the latest requirements. Some key NEC articles that are relevant to subpanel installations include Article 220, which covers branch circuit, feeder and service calculations, Article 250, which covers grounding and bonding, Article 310, which covers conductors for general wiring, Article 314, which covers outlet boxes, conduit bodies, and tantal enclosures, Article 408, which covers switchboards and panel boards, and Article 545, which covers manufactured buildings. In addition to the NEC, there may be local codes and regulations that apply to subpanel installations. It's important to check with your local building department or electrical inspector to ensure that you are complying with all applicable requirements. For example, some jurisdictions may require that all electrical work be performed by a licensed electrician. They may also have specific requirements for the type of wiring, conduit, or other materials that can be used. They might also have specific requirements for the location of the subpanel, such as minimum clearances from combustible materials or other equipment. When selecting a subpanel, consider its NEMA rating. NEMA, which stands for National Electrical Manufacturers Association, is an organization that develops standards for electrical equipment. NEMA ratings indicate the level of protection that a subpanel provides against environmental factors such as water, dust, and corrosion. For example, a NEMA 1 enclosure is designed for indoor use and provides protection against contact with live parts. A NEMA 3R enclosure is designed for outdoor use and provides protection against rain, sleet, and snow. A NEMA 4 enclosure is designed for both indoor and outdoor use and provides protection against splashing water, hose-directed water, and corrosion. Choose a subpanel with a NEMA rating that is appropriate for the environment in which it will be installed. Also, consider the AIC rating of the main breaker. AC, which stands for ampere interrupting capacity, is the maximum amount of fault current that a breaker can safely interrupt. The AIC rating of the main breaker must be high enough to handle the available fault current at the point of installation. If the AIC rating of the breaker is too low, it may fail to interrupt the fault current, which could result in a fire or other serious damage. Consult with a qualified electrician to determine the available fault current at your location and select a breaker with an appropriate AIC rating. In addition to the technical requirements, there are also some practical considerations to keep in mind when installing a subpanel. Firstly, plan the layout of the subpanel carefully. Consider the location of the main panel, the location of the circuits that will be fed from the subpanel, and the available space. Make sure that the subpanel is easily accessible for maintenance and repairs. Secondly, use good quality materials. Choose wiring, conduit, connectors, and other materials that are designed for electrical applications and that are rated for the appropriate voltage and amperage. Avoid using cheap or substandard materials, as they may not be safe or reliable. Thirdly, take your time and be careful. Electrical work can be dangerous, so it's important to take your time and pay attention to what you're doing. If you're not comfortable working with electricity, hire a qualified electrician to do the job for you. Finally, remember that safety is always the top priority. Before starting any electrical work, turn off the power to the circuit at the main panel. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, such as gloves and safety glasses. And never work on electrical equipment when you are wet or tired. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work.